In this power flow project, we have this particular network. Let's try to understand the network and how many number of buses are there, how many number of generators do we have, and where are the transformers, what are the voltage levels. So if you look at this particular network, this dark dot points are nothing but generators, and we can understand that there are three generators in this total network, and it is also understood that the entire network with the thick lines is a network with 161 kV. So you can understand that all the buses with this in this part of the network are rated at 161 kV. And then you can see that here is a transformer, and after the transformer the dotted network is operated at a 69 kV. So now entire this dotted network is operated at a 16 kV, and you can also see that there is a second transformer. It tells you that there are two transformers in this network which will be rated at 161 kV divided by 69 kV. So in total, this bus number 17, 10, 13, and 16, these are the four buses which will be at a voltage level of 69 kV. The rest of the buses in the network will be at a voltage level of 161 kV. Another observation that you can have from this particular network is that there is a box here. Within this box is what we call it as an urban area. External to this box is considered as a rural area. So whenever you enter your data, you can say that there are two areas, and you can consider the rural area as one and urban area as two, and enter your data accordingly. So as a whole, in this particular network, we have three generators, and you know that generators are at bus number 1, 2, and 3, and there are two transformers. One transformer is between 15 and 16 bus, and another transformer is between bus 9 and 17. And there are two areas, and the urban area and rural area. There are two voltage levels, that is 161 kV, which is the thick lines representation of the network, and 69 kV is the low voltage network, relatively, that is bus number 17, 10, 13, and 16. Now we already have the information about the three generators, and then we also have the amount of loads at each and every bus. The transmission line parameters are given in the problem itself, but the transmission line parameters, resistance, reactance, and conductance in the last three columns of the transmission line parameters are given in terms of ohms, actual quantities, which needs to be converted into per unit values. So we already gave another table where we have converted all these numbers into per unit values based on the base ratings that we have. You can observe that these numbers have been highlighted in per unit. So with the lines data and also the loads data that we have here and generators information that we have here, can start creating a case in PSSE. And if you open your PSSE, then this is how your PSSE looks like. You can create a new case data by going to the file on this leftmost corner. In that you can go for an option new, and then there create a case data. Once you say that you want to create a case data, that gives you a pop-up saying build new case. We always go for 100 MVA as base and 60 Hz as a frequency, and you don't have to change anything here. Just say OK. After that, you can enter the information about your network. And at the bottom, you can see that there are different tabs which talks about bus, plant, machine, load. So bus is about, you will be giving information about the number of buses you have in your system. And plant and machine will be about generating plants. And load will be about the loads that you have in the system. So all these are related to bus and equipment data. Then you will have this next tab that you can see on the bottom. that is branch. When you are giving branch data, that is lines data, that is where you have AC lines data, and we also have a two-winding transformer in our test case. There are two winding transformers, so we need to enter that data. To start with, we'll go for bus and equipments. You can have a look at the bottom here, bus and equipment, and there you go for bus data. In order to enter that bus data, you can see that there are totally, observe the network. The number of buses that we have are totally 17 number of buses. So we need to enter that 17 bus data. So to see that, okay, what will be filled default, just go to that bus. So you can see that buses and equipments option, and we are in bus. And go to bus, enter that bus number 1, and then after you enter the bus number 1, go to the next row, that is to the next row. If you go to the next row and enter the bus number 2, by the time once you go to the next row, the information related to bus 1 will be filled automatically. You don't have to enter anything else. That's where you will realize that what is taken default and what you can modify. Now, with respect to bus number 1, now you start editing the bus number 1 data. You enter the bus number, section and substation. You don't have to modify anything. Go to the bus. That's where you give the name of the bus. The first bus naming that we have is OWL. And then base kV for bus is 161 kV. So you don't have to mention that K there because it is already having is kV units. So 161 will be your answer. Now we mentioned that there are two areas. So we consider that the network outside the box here, that is network outside the box here as area 1 and network inside this box as area 2. So you consider this area as 1 for the bus number 1. And then you don't have to change anything on the zone as well as owner. And but when it comes to code, there are three generators. Now it is given in the PSSE manual that we provided to you that the code will be 3 if it is a reference or slack bus. Code is 2 if it is a generator bus. Code is 1 if it is a load bus. So you enter the code here as 3 because you want to take the bus number 1 as the slack bus. And then at this bus, you need to give information on the voltage. So you can take 1.03 or zero 0.04 because we clearly mentioned in that reference document that you can take voltages for the generators between 1 and 1.04. You can have a look at that data here, where we mentioned that you can take the voltages somewhat like this, but here we clearly stated at this particular statement in page number 5 of the assignment itself to take your voltages which are close to 1.04, maybe slightly higher than 1 but less than 1.04. So that's why I take the voltage here as 1.03, angle I consider it as 1. After that, the rest of the numbers, the voltage min max limits at that particular bus, you don't need to change anything. So now for the second bus, you can enter that name, that is name of the bus is Swift. Base kV for second bus is also 161. Area is 1 as we mentioned. And second bus also we have a generator, so you can take code as 2, the voltage as 1.03 or 2, whichever you feel, it doesn't matter. And now next, after the second bus data, you can go down to third bus, enter 3. Once you enter the third bus 3, then the next row will be automatically created. So don't have to worry about that. So after that, you can move on to the bus name, that is parrot. Then the voltage levels of this bus are 161. and area is 1 for us. Zone number you don't have to enter, and if you wanted to see the default numbers to be automatically filled, then after you enter this 3 here, you can press down and all the numbers will be auto entered. Then the only thing you need to change is the bus code, that is 2 here, and voltage you can take it as 1.02. Angle you don't have to choose. And go for the bus number 4 and press down. Then the information of the bus number 4 will be auto filled. Then you start modifying the data that you want. Fourth bus is long, and the voltage level of the fourth bus is 161. And then the area that we have for the fourth bus is 2. The fourth bus is not a generator bus, so the code will be 1. And since it's not a generator bus and it's a load bus, the voltage and angle you don't have to worry because they will be updated after the load flow. Like that, you can go for your bus number 5 and then press down. Then it will be auto filled. And fifth bus name is J. The voltage levels of the fifth bus are 161 kV. And then area for the fifth bus is 2 because it is inside that area box that we have, and you don't have to modify anything. So like that, you can enter the buses, that is 5, 6, press down arrow so that the information will be filled, and you can edit whatever is needed later. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So these are the buses we have. You can name them from 6 to 17, whatever the names we have. So once you name them, you'll be getting that names that way. Then you can enter the voltage levels. And you know that there are only 4 buses with the voltage level of 69. So once you enter the voltage levels, the 10th bus is at a voltage of 69 and 13th bus is at 69, 16 and 17 are at 69. So now after that, you have entered your data. You can observe that the total number of buses and the naming for the buses, the voltage levels of the buses we have entered, area. You can clearly see that the area is 2 for 4, 5 and 6, 7, 8. You can modify that. The rest are in area 1. We haven't changed anything for zone owner. For bus code, first bus we have taken it as the slack bus, that is 3. Second and third are generator, rest are the loads. And we gave voltage values for all the 3 generators, even if it is a slack bus. We haven't edited anything on the angles. The rest of the information we will not be modifying anything. We can keep it as is. So to save that case, after you enter the bus data, you can go for the plants or the machines. So if you try to enter the machines, that is bus number 1, you have a 1 generator, then go down. It will tell you that, okay, do you want to change bus code to 2 because it is a generator. But first bus code, we want to retain it as 3 itself. So we'll say no for it. So bus code will remain 3 because that's a slack bus. You enter 2 and press down arrow. That's when it will try to autofill the entire row. While autofilling the entire row, it will give you the same question. You want to have the bus code type to 2? Yes, we want to have. Since anyway you already gave that bus code to 2, you can say yes or no, it doesn't matter. And bus number 3 is also a generator bus. Press a down arrow, it autofills the information. Only thing is you can give your voltage values that are scheduled here. That's what for the generators, it wants you to give what voltage you wanted. Apart from that, the information that we need to fill for this generator is what is the amount of P generation and also what is the amount of P minimum and P maximum. Q generation we don't enter, but we need to enter that Q max and Q min. Now if you go back and see the information given for all the 3 generators that we have, you can see that the generators P max is 490 and Q max is 250, Q min is minus 100. The P generation for the slack bus, we don't mention that, we don't have to. But for other 2 generators, the generation is 190 megawatt. So with that, generator 1 you don't mention, but generator 2 190 and generator 3 is 190. In P max, we were given the values. You can see that the P max is 490. So you will be entering that values of 490 here. P min can be taken as 0. Q gen you don't mention, but P max, Q max and Q min we have to. You can see that the Q max is 250, Q min is minus 100. So Q max is 250, 250 and 250. And Q min is minus 100, minus 100, minus 100. So we enter that data. After that, you don't have to give any much information on the sources that you have, but provided you have any source reactances that you may be doing further analysis, that's when you need that information, but here we don't need that. So this gives you the information that you need on the generators. So in a way, you mentioned which one is the slack bus, that is code 3, and others are generator buses. You have given the voltage schedule and you entered what is the power generation, P max and P min. Q generation not needed because that will be generated or decided after the power flow, and we have Q max and Q min values being entered here. You can just save your data there. After the machines, you can see that the plant data being automatically updated because those are the 3 plants that you have. So you don't have to worry about entering the plant data by yourself. If you enter the machine data and you give your voltage scheduled and everything else, the plant data will be auto-feeded. Now comes the loads, and now you know that the loads are from the 4th bus because 1, 2, 3 are generator buses. You can enter the 4th bus as the load. And as I said, you don't go to the right side and keep entering the data. The simplest thing is press a down arrow here, then it will autofill that 4th bus information. Now at the load, because we are entering the load information, the only thing that you need to specify is the values of P load and Q load. I repeat again, the load, everything else will be auto-filled. The only information you need to enter is the values of P load and Q load. With the 4th bus, P load that we have is 78 megawatt and the Q load that we have is 13. So once you do that, that is enough. Now you can go to the starting 5th bus. You have a load. As I said, instead of going to the right, if you press a down arrow, the information of the 5th bus will be auto-filled. The only thing that you need to enter here will be P load. Now the P load at the 5th bus is 130 megawatt and Q load is 39 MVAR. So you can enter 130, sorry, I need to say that this is 6 and then total 130, and then we have 39. For the sixth bus, we have 104 and then 19.5. You can say seventh bus, you said go down, it will autofill, then you will enter only the amount of load there, 117 and 26. That's how you enter all your load data. Now we have load at 8th bus, going down, 9th bus, 10, 11, 12, 13, 14, 15. You can also enter all the values of the loads there. So once you enter all the load information, you can also save it for the not losing the data. Then after that, you have your bus data, you have your plant and machine data, also load data. That's all about the bus and the related equipment. Then you can move to branch data. In the branch data, you can observe it in the bottom. You can select the branch bar and go to the AC line. That's where you enter information of the lines there. Now in this, you give your starting bus, let's say the first bus, and the line is between bus number 1 and 9. And after that, you press a down arrow after giving from bus and to bus, then it will autofill the information of that line. After that, you need to give only the data on the line resistance, reactance, and charging B. And in terms of per unit quantities, we know that these numbers are given in the problem itself. You can enter that numbers. You can see that is given in our data we have from bus number 1 to 9, what is the information. And the rating also you can mention that. You can go and see that where is the rating after that values. So here you can mention the value of the rating that you have given, that is 252.8 is our rating there. So that's where you can enter your rating. So that's how you can also give whatever is the rating that you were given, and we have two different ratings given in the problem. Rating 1 and emergency rating, that is 265.4. You can give that rating 2 as 265.4. So that's how you'll be giving only these three values, and the rest of the information is about the rating. And about the length and everything, that is also some more information that we have in the line parameters here. If you want to enter that line length and all, you can also enter that line length in the respective column. So here we have length. The length of this line is 24 miles, so you can give that number as 24 for us. So you need to understand that you are entering the information about the starting bus. Let's say for the second line, starting bus is 1 and the ending bus is 11. Then you just go for a down arrow, then it will autofill all the information. And once it fills the information, you need to enter these three values: line resistance, reactance, and charging B. So if you enter those three numbers, let me say I'm giving that 3. After that, you also need to give the rating of the line. You can see that the ratings are also specified in the tables that you have. In fact, that is same for the first line and second line. And then the length of the line, that is also given, 36.7 for the second line. So that's what is the information that you need to enter for the transmission lines. Like that, you need to fill all the information about the transmission lines. So once you are done with the lines, you can go for the transformers. So we have two transformers in our network, which are two winding transformers. Now if you see where these transformers are, the transformers are between the bus number 9 and 17 here and 15 and 16 here. So when you enter the information on the transformers, you have it between 9 and 17. You enter the from bus and to bus, then press the down arrow. It will auto fill the information about that particular transformer, and then you don't disturb any other information on the transformer, but you have the specified reactance of the transformer. So what is the specified reactance of the transformer? It is given in the problem, and if you convert that into per unit, you will be having it as 1.0.133. So that is what is the transformer reactance. And we also have the rating of this transformers, that is a nominal rating of 60 and emergency nominal rating of 60 and emergency rating of 66. So that's what is the transformer information. So remember that you are entering these three, that is specified reactance, rating 1 and rating 2. The lower and higher voltages will be auto decided once you enter your starting bus and ending bus. Similarly, for the another transformer, it is between bus number 15 and also bus number 16. Now if you press the down arrow, it will auto fill the information about that transformer. And now you can go for the reactance, which is 0.133, and the rating as 60 and emergency rating as 66. So 10% higher than the nominal rating. So this is how we'll be able to get our network data being um, incorporated as a case data. So once you have your case data, that is when you can run your power flow and do the analysis and have your report. So once you have entered all your data, then you can go for your power flow option and then go for a solution and ask for to the solving the load flow problem. And you can even keep this settings as default and then solve it. You can see that at the bottom you will get met convergence tolerance. Then you can also say that okay, go to power flow, go for the reports, and ask for bus based reports, which will generate the power flow output at all buses. You can see that that's what we opted for. Go and then close. And when you go at the bottom, this is study report, but you can say that in the network, you can have a look at, there is an option called reports. And on that, if you click on that bus plot, that will basically update here. This is what is basically the results that you have, which you can utilize and analyze and basically understand what is the power flow solution for this particular case. And accordingly, you also have certain extra cases to run based on changing the load conditions, where you can modify the loads on the system and also run the load flow, and you can also trip certain lines and see what how that contingency is impacting your system and certain other cases. That's how PSSE power flow can be solved using our network that we have.